Hello, everyone. This is our recorded discussion for a descriptive statistic tool, which is a measure of central tendency and variability. This topic will be divided into two parts. So the first part will be discussing central tendency, and later we will also be making recorded discussion for measures of variability. These are the learning outcomes for this topic. Explain the meaning and the function of measures of central tendency and measures of dispersion through solving related problems in classroom assessment. Distinguish among the measures of central tendency and measures of variability, and be able to explain meaning of normal and skewed score distribution. So to start with, let's understand the concept of measures of central tendency, which is a single value that attempts to describe a set of data by identifying the central position within that set of data. So if we're going to compare it with measures of variability, we are like looking for where is the central location of the scores concentrated. Compare with variability, we are concerned with how far are the scores in respect to the mean or the average score. So again, central tendency, we are concerned with where the scores are concentrated or the central location of the scores, and measures of variability or measures of dispersion talks about how far are the scores from each other in respect to the average score or the mean. So the most commonly used is of course the mean, or what which we call the average, but we will also be discussing median and mode. So we will be dealing with two types of data here. We will have first the ungrouped data or the raw data, and later we will have the group data or the one that which is presented in uh, frequency distribution table. So the mean is equal to the sum of all the values in the data set divided by the number of values in the data set. So this is just like so simple. This is the formula. So if you will be given with this data, you just have to add them all together. 72 plus 75 plus 77 plus 79 plus 80 plus 83 plus 89 plus 92 plus 94 plus 97 all divided by 10 because we have 10 set of data. So this goes with if we will be computing it, that would be all right. Let me just recheck. So again, the process is to add everything and then divide by the number of data in this data set. So if you're looking for a calculator in your phone, you can download NCalc, or but during the exam, I would be requiring you to have a scientific calculator. Okay, so the sum of all the data set is 838 divided by 10. That gives us a sample mean of 8.38. Okay, So what would be the interpretation of this one? So that means there are 6 scores. If our, sorry, that should be 38, 83 rather. That's not 8.38, but 83.8. So the interpretation now would be there are 6 scores below the average, which are 72, 75, 77, 79, 80, and 83. And there are 4 scores above the average, which are 89, 92, 94, and 97. So more likely, we would say that there are a lot who scored below the average and lesser who scored above the average. So when not to use the mean? So there are limitations as this type of statistical tool is commonly used. There are somehow limitations to it. First is it is susceptible to outliers. So what does it mean? It is not reliable to use in a data set with highest in which there is an extremely low score or an extremely highest score because mean talks about the average. So it is only applicable for data sets that are close to each other. So if mean is not for scores that has extreme scores or extreme or outliers, median will be used for that. So this is an example of data set in which there is an extremely low and extremely high score. Here you can see we have 5 and we have 95. So there is a big range of scores. So median now will be used to describe that set of data. But how do we get the median? For ungrouped data, we have to arrange it. And then we have to identify the total number of data. This one is important because if your n is even, that means to say if we have like 4, 6, 8, 10, 12 number of data set, that means we have to interpolate. Means to say we have to find, because the location of the median would fall in the 2 middle scores. So that means to say we have to find the average of, or interpolate means we have to find the average of the 2 scores in the middle. However, if our n is odd, there would be no problem because we just have to find the middlemost score. Okay? Right. So let's have an example for that. Here, we have 65, 55, 89, 56, 35, 14, 56, 55, 87, 45, and 92. So you can pause the video and then you can arrange this one for yourself. So, of course, our first data would be 14. If we're going to arrange it, 14. We have 35. And then we have 45. And then we have 255. We have 2 scores, which is 56. We have 65. We have 87. We have 89. And we have 92. So to check, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is exactly the 11 students being mentioned in the problem. So since this is an odd number of, what we call this, data set, then all we have to do is to find the middlemost. So if we have 11, the middlemost will be the 6th number. So 1, 2, 3, 4, 5, 6. So that means to say our median is 56. So it just to give you a tip, to get the median or to get the middlemost or the location of the middlemost score, you just have to divide your n by 2 and then always round up. So for example, you will be given a data set which is 13, then that means to say 13 divided by 2, that's 6.5. That means to say you're going to look for the seventh um, element or the seventh data in that data set. Okay, so we can now describe this data. We can now interpret. So our median is the score at the middle of the distribution. So in this case, there are 5 scores below and then 5 scores above it. Now let's have an example in which the data set is even. So here, of course, we can arrange this one to 14, 35. We have 45. We have 255. We have 56. We have 87. We have 89. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, we missed 1, 14, 35, 45, 55. We have 256. Oh, sorry, we have 65 rather here. Okay, so if we're going to find out which is the middlemost, we can say that this is the 5th and the 6th number because we have 10. So this is the time that we have to interpolate, and we say 55 plus 56 divided by 2, that gives us 55.5. This is now our median score. So the interpretation would be gives a more reliable picture of the tendency of the score. So there are indeed 55 and 56 in the score distribution. Now, for mode of a ungroup data, there is actually no need for us to calculate. All we need is to arrange them. 14, 35, we have 45, we have 55, we have 56, we have 65, and we have 87, and we have 89. So if we're going to observe, we have two numbers, two data that is frequently observed in this data set. So remember that when you say mode, it is the most frequent number or frequent data in that given values. So here we have 55 and 56 as our mode. We have 55 and 56. And this distribution in this data set is called bimodal because we have two modes from it. However, if we only have one, we have unimodal, we have trimodal for 3, and we have multimodal if we have more than 3. So the interpretation would be there are two most frequent scores, which is 55 and 56. So you have a score distribution with two modes. This is called bimodal distribution. Now let's proceed to group data. Unlike with ungroup data, calculating for mean, median, and mode in group data, we will be needing our formula application. So here, we have here the formula, and this is read as the summation of all the product of the frequency times the class mark divided by the summation of the frequency. So let's just name this frequency f as our frequency and x as our class mark. So how do we compute for the class mark? Class mark will just be your lower score or lower limit plus upper limit divided by 2. So how do we solve that? We can just add an additional values here. So that would give us 40 plus 49. So that's 40 plus 49 divided by 2. That gives us 44.5. And we can continue that value or that formula up until the end of our class interval or class limit. So this one would be 54.5. This one would be 64.5. This one would be 74.5. This is 84.5. And this is 95. So right after we have solved the class mark, the next step is to multiply. We have to multiply the frequency to its given. We have to multiply the frequency, the class mark rather that we have solved earlier to its given frequency in the table. So we will have, that means to say, we will have x times frequency here. And that would give us 133.5. Again, this is just from 3 times 44.5 value. Okay, and we continue that. That gives us 2,072.5. This is 387. This is 670.5. This is 676. And this is 665. So now, since we have to abide with the formula application, we have to, as the numerator says here in our formula, we have to compute or we have to add all these values for us to look for the summation of the product of frequency times the class mark. So we have 2,804.5. And we also have to add our frequency. If we will add this, this will be equivalent to 38. So now we have now the value for our numerator and our denominator in the given formula. So we can say that the mean of this given distribution is equivalent to 2,804.5 divided by 38, and that gives us 73.8. So this is now our mean. Okay, now for our median, so we have a lot of values, but we will be discussing them one by one. The L here represents for the lower class boundary of the median class. So that means to say, we have to identify first which is our median class, which is our n over 2. That would be, since we have calculated this one already earlier, so we are just using the same set of data. This is 38, or that is also our n, our capital N. So here we have 38 divided by 2. That gives us 90. Now, for the cumulative frequency that is before the median class, we have to make the cumulative frequency of this distribution lesser cumulative frequency. which I believe we have done it in our introduction topic. And also, we have to solve for the class size. Our frequency of, this is now our frequency of our median class. So with that, the first thing we need to do is to add here another column for the LCB, or again, the lower class boundary. Again, how do we solve it? That is just always the lower score minus 0.5. So for example, we have 40, that becomes 39.5 because that's 40 minus 0.5, that's 39.5. And 50 minus 50 minus 0.5, that would be 49.5, and so on. So you can pause the video and you can solve it in your end. 69, this will be 69.5, this will be 79.5, and this will be 89.5. So this is our lower class boundaries. Now we have to make the lesser cumulative frequency. Now take note for the lesser cumulative frequency, this should always start with the lowest class interval. If we're looking for the greater than cumulative frequency, we will start with the highest class interval. So since this is lesser, so we will start here with 3. So whatever is the frequency of that, you copy that as its own lesser cumulative frequency. And then you need to look for the next frequency. Here, the next is 5. And then you add that to the previous one. So that gives you 3 plus 5, that's 8. And then you do that continuously. So 8 plus 6, that is 14. 14 plus 9, that would be 23. 23 plus 8, that would be 31. And 31 plus 7, that would be 38. Exactly the same value that we have for our summation of all the frequency for our n. So with this, our next step is to identify the median class. So the median class will always be where our n over 2 located. Again, the median class will always be, I'm going to write it here, the median class is where in the lesser cumulative frequency n over 2 is located. So with that, if we're going to observe the lesser cumulative frequency, we have this as our median class. Why so? Because if we pick 14, that would be a lesser than 19. But if we pick 23, we're sure that that 19 is located before 23. So this is now our median class. So with this, what we're going to do is to identify now. So our L will be 69.5 because that is the lower class boundary of our median class. The next is we have the lesser cumulative frequency before. So that would be 14 because that's before. And we have the frequency of the median class, which is 9. The class size, which is 10. Why so? Because that is 49 minus 40 and then plus 1. Or we can just count it in our fingers. It's 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. That is all 10. So that's the class size. Now, we can just input that in our formula. We'd say median is equivalent to 69.5 plus 19, because that's our n over 2, or 38 divided by 2, minus our lesser cumulative frequency below or before, divided by our 9, which is our frequency of the median class, times 10, which is our what we call this class size. So we can put that one in the calculator. We can also manually do it. 5 over 9 times 10. So if we do the calculation using our calculators, our median would be 74.36. Or that would be, sorry, it's not 74.36. So if we say that's 75.01, 75.06, or that could also be equivalent to 75.1. Okay, round off. All right, so that's it. For the mode, this will just be very quick because all we have to do is to find our D1. D1 is the frequency of our modal class minus the frequency before our modal class. And D2 would be the frequency of the modal class subtract by the frequency after that modal class. So before we use the formula, we need to find out which is the modal class. So the modal class is where the scores are highest, or is where the class interval has the highest frequency. So it has the highest frequency. So if we're going to check, of course, it's clear that we have 70 to 79 as our modal class. So the values L and I are the same with computing for median. It's still the class size, and L represents for the LCP. So we have solved this one already previously. So I'm just gonna fill this out. This is 69.5. This is 79 rather, 0.5. And this is 89.5. So that means to say that since this is our modal class, this is also our lower class boundary of the modal class. So our mode now will be computed as 69.5 plus our D1 is 9 minus 6. Why so? Because we have 9, and then before that is 6. And our D2 would be 9 minus 8, because that's after. So that gives us D1 would be 3 divided by 1 plus 3. 3 plus 1 as our D2 times the class size, which is 10. So if we solve this is 69.5 plus this would be 0.5 times 10. So this one would give us 77 as our mode. Okay, so that's how we solve for the mean, the median, and the mode in a central in a group data. Okay, so now how is this statistical tool related to our assessment learning? So there is what we call normal distribution. So it is a distribution where mostly the mean, the mode, and the median are concentrated on the center of the bell curve. And when it comes to assessment of learning, that means to say we have equal average, median, and mode of the scores of the students. So to put that one in put that one in the graph, this will be the general phase. So when we say normal distribution, this is the phase of that. However, there would be cases that our the distribution of our student score is below the mean. So if that's below the mean, that would be positively skewed. Or there would be also cases that the distribution of our students' score is above the mean. So that would be negatively skewed. So in assessment of learning, we want to have, ideally, we want to have a negative skewed distribution because we want to have our students to pass all our assessment or our evaluation or our, it could be formative assessment or summative assessment. But somehow, there are cases that we cannot control the mixed class we have. So at least our goal is to achieve a normal distributed scores. If ever that our evaluation results or summative results or formative assessment results fall under positive skewed distribution, that means to say we have to revisit our techniques because it might be that since most of our um, students is below the average score, it might be that uh, there is a misalignment of our teaching strategies or teaching delivery to our evaluation, to our assessment tools. So that's why we have to revisit, we have to check. So that's now the application of mean, median, and mode in the assessment of learning. So take note, positively skewed, that means to say most of our students scored below the average. And negatively skewed, most of our students scored above the average. And that will be it for this um, video discussion. The other half for measures of variability will be done after this. Thank you so much.